Imagine our planet, not as a vibrant blue marble, but as a white cue ball, a perfect sphere of ice kilometers thick, reflecting the cold light of a distant sun back into the empty void. An alien world, silent and frozen, where the oceans are solid and the continents are buried. This isn't a scene from a science fiction movie. This isn't a vision of a distant, dying star. This was Earth. For 50 million years, our world was entombed in ice, a catastrophe so complete it should have sterilized the planet for good. The story of how it happened, and the miracle of how life survived, is the most important ghost story you've never heard. If you're using these to fall asleep, that's literally why I make them. The stories of our planet are the greatest epics ever told, so subscribe maybe, and tell me where you are and what time it is. I read the comments and it's like having breakfast with someone in Berlin while someone else in Boston is just heading to bed. It is the greatest reminder that we all share this one tiny rock. Now, before you get lost in a world that existed 720 million years ago, a world so strange you won't believe it's our own, make sure you hit that subscribe button. You don't want to miss what happens next. Picture this. You are standing on the edge of a continent 720 million years in the past. The very ground beneath your feet feels wrong. It is barren, empty rock. There are no plants, no trees, no grass, not even a patch of moss. The land is a silent world of red and brown, a vast, sterile desert that stretches for thousands of miles. All the continents of Earth are currently gathered into one enormous, unfamiliar supercontinent called Rodinia. It's like a broken piece of a giant puzzle, a landmass so huge it creates its own brutal, dry climate in its interior. The only sound is the wind, whistling across an empty world. But the real story isn't on the land, it's in the water. You walk to the coast and look out at a primordial sea. The water is teeming with life, but not life as you know it. There are no fish, no sharks, no whales, no coral reefs. Instead, the shallow coastal waters are covered in strange living carpets, microbial mats, billions of single-celled organisms all living together, forming a slimy greenish-brown layer that covers the seafloor. And rising from these mats are bizarre, mushroom-shaped pillars of rock. These are stromatolites, underwater cities built layer by layer over thousands of years by photosynthetic bacteria. For nearly 3 billion years, this is what life on Earth has looked like. Simple, resilient, and, to our eyes, incredibly basic. This is the Cryogenian period. The sun in the sky is fainter and cooler than the one we know today, giving the world a slightly dimmer, colder light. For 1 billion years leading up to this moment, a period scientists literally call the boring billion, evolution has been stuck in first gear. Life had figured out a successful formula with single-celled organisms, and it saw no reason to change. The planet's climate was stable. The oceans were chemically balanced. It was a world that worked. It was a successful experiment. But it was also a world without brains, without bones, without blood. A world where the most complex creature was a simple strand of algae. It was a planetary-scale petri dish, and it had stayed that way for longer than all of animal history combined. There was no reason for any creature alive at the time to think things would ever be different. The rules had been set for eons, but the planet itself was growing restless. Deep beneath the oceans, the tectonic plates were shifting. The great supercontinent of Rodinia was beginning to groan and stretch. It was starting to break apart. And this continental breakup was about to trigger a chain reaction, a perfect storm of geological and chemical events that would plunge the entire planet into a crisis unlike any it had ever seen. The very rock beneath the oceans was about to become a weapon against the atmosphere, slowly and silently stealing the planet's thermal blanket and exposing it to the killing cold of deep space. For 1 billion years, life had been simple and stable, but the world was on the verge of a catastrophic fever break. the quiet, boring, microbial world was about to be put on ice, and the stage was being set for a planetary apocalypse that would ultimately pave the way for a new kind of life, us. For 1 billion years, the rules of life had been simple and the planet's climate had been stable. But the slow, inexorable breakup of the supercontinent Rodinia was about to change everything. This wasn't a fast or violent process. There were no cataclysmic earthquakes that shook the globe. Instead, it was a quiet, relentless tearing apart, a planetary-scale continental drift that unfolded over tens of millions of years. Imagine a vast sheet of ice cracking under its own weight. That was Rodinia. Enormous rifts began to form, valleys that stretched for thousands of miles. Over millennia, these valleys widened and deepened until finally the ocean poured in, creating new shallow seas where there was once dry, barren land. The single great continent was shattering into smaller pieces, and this breakup was setting the stage for the greatest climate catastrophe in Earth's history. The most important detail of this story, the clue that unlocks the entire mystery of the coming freeze, is geography. The breakup of Rodinia was happening right at the planet's equator. Think about that. Thousands and thousands of miles of new coastlines were being created, with fresh, raw, unweathered rock being exposed to the air for the first time in eons. And all of it was located in the warmest, wettest part of the world, the tropics. This single fact, the creation of vast tropical shorelines, was the loading of the gun. The weather would pull the trigger. To understand how this caused a global freeze, we need to talk about the planet's thermostat, carbon dioxide. CO2 is a greenhouse gas. It acts like a thermal blanket in our atmosphere, trapping heat from the sun and keeping our planet warm enough for life. During the Cryogenian, the sun was significantly fainter than it is today, so this blanket was even more important. The Earth relied on a thick layer of CO2 to stay warm. So what happens if something starts to steal that blanket thread by thread? The planet gets cold, and that is exactly what the breakup of Rodinia started to do. The process is a kind of geological magic, a great carbon heist performed by nothing more than rock and rain. It works like this. Rainwater naturally absorbs carbon dioxide from the atmosphere, forming a very weak acid called carbonic acid. It's the same stuff that makes your soda fizzy. In the tropics of the Cryogenian, it rained a lot. This warm, acidic rain fell relentlessly on the immense new coastlines of fresh volcanic rock, a type of rock called basalt. When the carbonic acid in the rain met the silicate minerals in the rock, it triggered a chemical reaction, a process we now call silicate weathering. This reaction pulverizes the rock over millions of years, but it does something else far more important. It pulls the carbon dioxide out of the rainwater to form new minerals, like calcium bicarbonate. This process effectively takes gaseous CO2 from the atmosphere and locks it away in solid form. These new minerals, carrying the stolen carbon, then wash down the newly formed rivers into the new shallow oceans. There they are used by marine organisms, or simply settle on the seafloor, eventually becoming rock themselves, like limestone. The CO2 is buried, trapped for hundreds of millions of years. Think of it as a planetary-scale air scrubber. The breakup of Rodinia had created the perfect conditions for this scrubber to go into overdrive. It was a perfect storm of chemistry and geography. You had a supercontinent breaking apart right at the equator, creating the maximum possible amount of fresh rock exposed to the maximum possible amount of warm, wet, acidic rain. Every single raindrop that fell on these thousands of miles of coastline was participating in a colossal act of theft, stealing a tiny molecule of the planet's warmth and burying it at the bottom of the sea. It was an anti-volcano. While normal volcanoes pump CO2 into the air, this geological process was sucking it out with terrifying efficiency. Now you might be wondering, couldn't life have played a role? Didn't the algae and bacteria in the oceans also consume CO2? Yes, they did. But life had been doing that for billions of years, and the planet's systems were in balance with it. This was something new. This was the planet's own geology declaring war on its own atmosphere. The sheer scale of this new silicate weathering process was so immense that it overwhelmed the natural carbon cycle. For every ton of CO2 the volcanoes were putting into the air, the weathering of these new rocks was pulling out 2 or 3 or maybe even 10. The planet was now running a carbon deficit. It was losing its thermal blanket faster than it could weave a new one. This didn't happen overnight. It was a slow, creeping catastrophe, unfolding over a timescale we can barely comprehend. Imagine watching a swimming pool being drained with an eyedropper. For a long time, you wouldn't even notice the water level changing. That was the Earth's atmosphere. For millions of years, the CO2 levels were dropping, but so slowly that the effect was almost imperceptible. The global temperature might have dropped by a single degree over 1 million years, but the process was relentless. It never stopped. The rain kept falling, the rocks kept weathering, and the carbon kept disappearing into the sea. The planet's thermostat wasn't just being turned down. The thermostat itself was being slowly and systematically dismantled. The first signs of the coming winter would have been subtle. At the poles, which were already cool, the winter snows might have started to last a little longer into the summer. Over thousands of years, these snowfields would have compacted into the first permanent ice caps. In the tropics, the stifling heat might have become just a little more bearable, but the cooling was accelerating. As more of the CO2 blanket was stripped away, the planet became more sensitive to change. What started as a slow drain was becoming a waterfall. The system was being pushed towards a tipping point, a point of no return. The planet was getting colder, but the process was still slow, still linear. Nobody could have predicted what would happen next, because the Earth had just created a new weapon against itself, a weapon that was bright, white, and grew with the cold, a weapon that would soon take control of the planet's climate and refuse to let go. The first ice sheets had been born, and they were hungry. The planet was getting colder. The slow, relentless theft of its atmospheric carbon dioxide was stripping away its thermal blanket thread by thread. For millions of years, this was a quiet, creeping chill, a subtle change that the simple life of the cryogenian would have been unable to notice. But the Earth's climate is not a simple linear system. It is a complex beast full of hidden tripwires and tipping points, and the slow cooling had just pushed the planet to the edge of a precipice. The first ice sheets born in the polar twilight were about to become the masters of the world. They were about to unleash a new kind of physics on the planet, a runaway chain reaction that would take the gentle cooling and turn it into a catastrophic, unstoppable deep freeze. To understand what happened next, you need to understand 2 very simple facts. Dark surfaces, like dark ocean water or bare rock, absorb energy from the sun and heat up. Bright, white surfaces, like snow and ice, act like a mirror, reflecting the sun's energy back into space and causing cooling. This reflective power is called albedo, and it was about to become the most dangerous weapon on the planet. As the initial cooling allowed the first ice sheets to grow at the poles, they covered up the dark, heat-absorbing rock and water beneath them. The planet was, in effect, putting on a white t-shirt on a sunny day. It was becoming more reflective. This meant that more of the faint sun's energy was being bounced back into space before it could warm the surface. This, in turn, made the planet even colder, and the colder it got, the more the ice sheets grew. And the more the ice grew, the more reflective the planet became. And the more reflective it became, the colder it got. This is a positive feedback loop, a runaway chain reaction. It's like a planetary fire that feeds not on heat, but on cold. Every new square mile of ice was another victory for the freeze, another step towards a point of no return. The Earth's climate was like a giant boulder that had been sitting atop a hill for 1 billion years. The slow drawdown of CO2 was the force that had been pushing the boulder, inch by inch, towards the edge. The birth of the ice sheets was the moment the boulder tipped and began to roll, and with every passing century it was picking up speed. Picture the slow, inexorable march of the glaciers. This was not a sudden cataclysm, it was a siege that lasted for thousands of years. Imagine you are standing on a coastline in the middle latitudes, somewhere that would one day become China or North America. For your entire life, the world has been getting colder. The winters are longer, the summers are cooler, and then one day you see it on the horizon, a shimmering white wall, miles high, stretching from one end of your vision to the other. The polar ice sheet has arrived. It is a mountain range of moving ice, a glacier so vast it dwarfs anything that exists on our planet today. Every year it advances, devouring the landscape. The sound is not of a storm, but of immense, grinding power. The deep, groaning sound of a continent being pulverized, the deafening crack of mountains of ice carving into the sea. The glaciers were not just covering the world, they were erasing it, grinding ancient mountains down to dust, carving new valleys, and pushing the planet's remaining life into an ever-shrinking band around the equator. Climate scientists who have modeled this event have calculated the precise point of no return, the tripwire. They believe that once the great ice sheets advanced from the poles to a latitude of around 30 degrees, roughly where the cities of Cairo or Houston are today, the feedback loop became unstoppable. At that moment, the planet's albedo, its reflectivity, became so high that the Earth was reflecting more of the sun's energy than it was absorbing. The planet was now actively refrigerating itself. The final snap freeze was terrifyingly fast. The process of the ice marching from 30 degrees latitude all the way to the equator may have taken as little as 1,000 years. In geological terms, that is a heartbeat. The world was about to be flash frozen. The final act of this planetary tragedy was the death of the oceans. The glaciers, having already consumed the continents, now marched across the sea. Picture the warm tropical oceans, the cradle of all life, the home of the microbial mats and the stromatolites for 3 billion years. First, the surface would have developed a thin crust of sea ice, like the Arctic Ocean today. But this was different. The ice never melted in the summer. Instead, it grew thicker year after year, century after century. A ceiling of ice was closing over the world, cutting off the sunlight. The vast communities of photosynthetic bacteria, the engines of the planet's biosphere, were plunged into an endless frozen night. And then the ocean itself began to freeze solid, the ice sheet growing downwards, until it was a solid shell, a mile thick in places, locking the oceans away in a dark, frozen tomb. The runaway chain reaction was complete. One by one, the last patches of dark, open ocean water would have frozen over until the entire planet shone with a brilliant, uniform, and horrifying whiteness. The great groaning of the glaciers would have fallen silent, their march finally over. From pole to pole, the planet was entombed in a shell of ice. The world's heart had stopped beating. For the next 50 million years, Earth would be a ghost, a white marble floating in the dark, and the great silence was just beginning. The runaway chain reaction was complete. The last patch of dark, heat-absorbing ocean had frozen over, and the planet had become a perfect, brilliant white sphere. The great groaning march of the glaciers fell silent, their conquest of the globe finally at an end. From pole to pole, the planet was entombed in a shell of ice, in some places a mile thick. The world's heart had stopped beating. The hydrological cycle, the constant movement of water from ocean to cloud to rain, had ceased. The planet was in a state of suspended animation. For the next 50 million years, Earth would be a ghost, a white marble, floating in the dark, and the great silence was just beginning. Picture our planet from space during this time. It is not the vibrant, swirling blue marble we know from the Apollo photographs. It is a perfect, featureless white ball, reflecting the sun's light with a cold, dazzling intensity. There are no blue oceans, no green and brown continents, no swirling white clouds. There is only ice. The surface is so reflective it would be almost blinding to look at. An alien astronomer charting this solar system would likely have classified Earth as a dead, frozen world, an uninteresting ice planet not worthy of a second look. The average temperature on the surface has plummeted to a staggering -50 degrees Celsius, that's -58 degrees Fahrenheit, colder than the most brutal winter day at the South Pole. This was the new normal. Now let's bring you down to the surface. You are standing on the equator, but this is not the lush, humid, vibrant jungle you would imagine. You are standing in the middle of the largest, coldest and driest desert the world has ever known. An endless, wind-blasted wasteland of ice stretches in every direction, flat and blindingly white under a harsh, unfiltered sun. The ice under your feet isn't smooth like a skating rink. It is a chaotic, tortured landscape of sharp-edged pressure ridges, deep, dark crevasses that plunge miles into the frozen ocean below, and strange, wave-like formations carved by a wind that hasn't stopped blowing for 10,000 years. Look up at the sky. It is a shockingly deep, crystal-clear blue, so dark at the zenith that it's almost black, even in the middle of the day. The atmosphere is incredibly cold and bone-dry, scrubbed of all its water vapor. There are no clouds. There is no haze. There will not be a single cloud in the sky for the next 1,000,000 years. The sun is a small, sharp, brilliant disk in this pristine sky. It provides a harsh, sterile light, but almost no warmth. The shadows it casts are razor-sharp and impossibly black. It is a hateful sun, offering light, but no life. The silence is the most profound thing you can imagine. No bird song, no insect hum, no wind rustling through trees. The only sound is the constant low whistle of the wind across the ice and the occasional terrifying deep boom that echoes for hundreds of miles. It is the sound of the ice sheet itself shifting under its own colossal weight. A reminder that even in this frozen stasis, the planet is not truly dead, merely sleeping. The glaciers are not entirely static, driven by the planet's own geothermal heat from below and their own immense weight. They are still flowing, but at a pace so slow it is almost imperceptible. This movement, however, is one of the most important parts of our story. For millions of years, this global ice sheet acted like a piece of planetary-scale sandpaper. As the glaciers flowed, they were grinding the continents beneath them into fine powder, pulverizing mountains, scouring valleys, and preparing a massive store of mineral nutrients that would one day be released into the oceans. The planet was, in effect, fertilizing itself for its own rebirth. The highest mountains of the pre-glacial world, the ancient ancestors of the Andes or Himalayas, might have poked through the ice sheet in a few places. Geologists call these exposed peaks nunataks. Imagine them, black, jagged fangs of rock jutting out from an endless sea of white, scoured clean of all life by winds far stronger and colder than any modern hurricane. These peaks were the only remaining pieces of the old world, lonely monuments to a planet that was gone. The day-night cycle would have been a thing of brutal extremes. The days blindingly bright from the sun reflecting off the endless ice. The nights unimaginably cold and terrifyingly clear. With no moisture or dust in the atmosphere, the stars would have shone with a fierce, unwavering intensity we can no longer comprehend, a cold, cosmic audience to a world in a coma. But was it completely dead? Could anything, absolutely anything, have survived in this planetary freezer? The surface itself was a zone of death. The combination of extreme cold and the intense, unfiltered ultraviolet radiation from the faint sun would have sterilized any exposed surface. Life, if it was to survive, had to find a place to hide. The experiment of life on Earth, after 3 billion years of success, had been reduced to a desperate, microscopic insurgency, fighting a silent, multi-million-year war against a planet that had turned on it. To any outside observer, the game was over. But they would be wrong, because deep beneath the killing surface, in hidden pockets of darkness and faint geothermal warmth, the planet's last, most stubborn survivors were waiting. They were not going to give up. The greatest story of survival was about to unfold, not on the surface, but in the hidden cracks of a world entombed in ice. For millions of years, this was the state of our world. A magnificent, terrifying, and seemingly lifeless jewel. To any outside observer, the experiment of life on Earth was over. A catastrophic climate failure had resulted in a permanent, sterile ice planet. But that conclusion, logical as it seemed, would be wrong. Because deep beneath the killing surface, in hidden pockets of darkness and faint geothermal warmth, the planet's last survivors were waging a silent million-year war against the cold. And they were not going to give up. The search for these survivors is one of the greatest detective stories in science, a hunt for clues buried under 700 million years of rock and time. So where could life possibly hide in a world entombed in ice? The surface was a death zone, scoured by wind and sterilized by unfiltered ultraviolet radiation. The answer had to be somewhere else. Let's take a journey to the first and most important of these hidden sanctuaries. We descend through a deep crack in the equatorial ice sheet. We go down and down and down through a mile of solid, creaking ice. We finally break through the bottom of the sheet into the ocean below. But it's not an ocean we would recognize. It is a realm of absolute darkness, under pressure that would crush a submarine, and the water is just a fraction of a degree above freezing. It is as close to a Dead Sea as you can imagine, but we keep going, down towards the seafloor, and then we see it. A flicker of warmth and light in the crushing dark. We've found a hydrothermal vent, a crack in the Earth's crust on the ocean floor, spewing a plume of superheated, mineral-rich water from the planet's molten interior. In this frozen world, these vents were everything. They were oases of heat in an ocean of cold. More importantly, they were oases of chemistry. The water erupting from them was a rich soup of chemicals like hydrogen sulfide and methane. And here, in the eternal night of the deep sea, a different kind of life was thriving. Life that doesn't need sunlight. Life that breathes chemicals. This is chemosynthesis. Around these vents, the seafloor would have been covered in thick, white carpets of bacteria, feeding directly on the chemical energy erupting from the planet's core. And these bacteria would have formed the base of a complete, self-contained ecosystem. A tiny pocket of life, totally isolated from the frozen surface. These vents were the planet's life support system, isolated campfires in a world of endless winter. Around them, the last embers of Earth's biosphere were huddled, waiting for the dawn. But what about the life that needed the sun? The photosynthetic algae and cyanobacteria that had dominated the planet for billions of years. Could any of them have survived? For a long time, scientists thought the answer was no. A mile of ice would block out all sunlight, but some researchers have a different theory, a hypothesis that our world wasn't a perfect hard snowball, but perhaps a slush ball. The idea is that at the equator, where the sun's rays were most direct, the ice might not have been a solid, static sheet. The intense sun, even though it was fainter, might have kept the ice in a constant state of turmoil, creating a vast, chaotic zone of slush, meltwater lakes, and temporary cracks. It would have been a brutal, unstable environment, but it had one crucial advantage. Sunlight could penetrate a few feet into the water and slush. Picture this slushy equatorial belt. It's not an ocean, but a chaotic, grinding desert of ice and water, and in that thin, sunlit layer of slush, life could persist. Hardy species of algae could have survived, like the pink-coloured watermelon snow we find on modern glaciers. These organisms would have been in a constant state of near-death, frozen for long periods, then thawing just enough to photosynthesize and reproduce before freezing again. It was life on the absolute edge, a desperate microscopic struggle unfolding in the thin, slushy skin of a frozen planet. So bacteria and algae survived. That's incredible in itself. But what about more complex life? Could anything more than a single cell have endured this 50 million year winter? This is where the story takes a truly shocking turn. Scientists, analysing ancient rocks from just after the snowball period, found something they couldn't explain. They found chemical fossils, specific molecules called steranes, that could only have been produced by a particular type of life. Not bacteria, not algae, animals. Specifically, the evidence points to the most basic animal imaginable, the demo sponge. That's right, the humble sponge. The first animals on Earth may have not just existed before the Great Freeze, they may have survived it. This is a mind-bending revelation. A sponge is not a microbe. It is a multicellular animal. It has specialized cells that work together. It has a body plan. It is, for all intents and purposes, the base of our own evolutionary tree. Finding evidence of them during the snowball period is like finding a flower blooming in Antarctica. How could they possibly have survived? The answer probably lies in those same hidden refuges, in the low oxygen freezing water near the deep sea vents, or in the slushy equatorial oases. These first sponges would have found a niche. They could have fed on the bacteria and algae that were also surviving there, filtering them out of the water. While the world was in a planetary coma, the first, faint heartbeat of the animal kingdom had already begun. The sponges were the ultimate pioneers, the deep ancestors who proved that animal life could endure the absolute worst the planet could throw at it. And the rocks are not the only evidence. The story is also written in our own DNA. By comparing the genes of modern animals, scientists can create a molecular clock that estimates when their last common ancestors lived. And that clock points directly to the Cryogenian period. The genetic evidence is clear. The ancestor of all animals alive today, from the jellyfish to the dinosaurs to us, was alive during the snowball Earth period. We are all the descendants of a creature that somehow survived the greatest ice age in history. The snowball Earth wasn't just a prison, it was a crucible. The intense, unrelenting stress would have acted as the most powerful evolutionary filter imaginable. In a world with almost no energy, no warmth, and no oxygen, life had to get creative. It's possible that this very pressure is what forced single-celled organisms to band together, to cooperate, to become multicellular in the first place. The first animal may have been born not out of opportunity, but out of sheer desperation. A group of cells huddling together for warmth and survival. A strategy that would one day lead to brains and bones and consciousness. Life had found a way to survive. But survival is not the same as victory. Trapped beneath a mile of ice or locked away in the deep dark sea, the last survivors were living in a planetary prison with no hope of escape. The freeze had lasted for millions of years, and it could last for millions more. Life had proven it could endure the freezer, but it couldn't escape it. Unless something could attack the ice itself, something from deep within the planet. The Earth, after 50 million years of silence, was about to start fighting back, and the weapon it would use was fire. Life had found a way to survive. But survival is not the same as victory. Trapped beneath a mile of ice in the dark, frozen sea, or locked in a slushy equatorial prison, the last survivors were living in a world that was stable in its state of death. The freeze had lasted for millions of years, and for all they knew, it could last for millions more. There was no hope of escape, no path to reclaiming the planet. The ice was a perfect trap, unless something could attack the freezer itself. Something from deep within the planet's core. After an impossibly long silence, the Earth was about to start fighting back, and the weapon it would use was fire. While the surface of the planet was a silent, frozen wasteland, the Earth's great internal heat engine had never stopped churning. Miles beneath the ice, the mantle was still flowing, tectonic plates were still grinding against each other, and volcanoes were still erupting. Picture this. You are in the deep, dark, frozen ocean, far beneath the ice sheet. A volcano on the seafloor erupts. But this is not the pillar of fire and ash we imagine. The eruption is smothered by the colossal weight of the ice above. Instead of a plume, the lava forms a vast, molten pool, creating a temporary cavern of melted water and steam, a violent, hidden battle between the planet's internal fire and the oppressive cold of its surface. For a time, the lava wins, melting a small pocket of the glacier from below. But the cold is too powerful, and eventually the water refreezes, the steam condenses, and the eruption is entombed. This scene would have been repeated thousands of times all over the planet for millions of years. A hidden, secret war between fire and ice. And on its own, it was a war the fire could never win. The ice was too thick, the planet too cold. But the volcanoes had a secret weapon. A weapon that was invisible, patient, and cumulative. With every single subglacial eruption, they were releasing gas. And the most important of these was carbon dioxide. This is the key that unlocks the door to the prison. In a normal, healthy world, the Earth has a balanced carbon cycle. Volcanoes pump CO2 into the atmosphere. This CO2 is then removed by two main processes. It dissolves into the liquid water of the oceans, and it is pulled from the air by the chemical weathering of rocks, the very process that started the freeze in the first place. It's a beautiful, self-regulating system that keeps the climate stable over geological time. But on Snowball Earth, that system was broken. It was completely shattered. The oceans were sealed under a lid of ice, so they couldn't absorb any CO2 from the atmosphere. The continents were buried under that same lid, so there was no rock weathering to scrub the CO2 from the air. The planet's two great carbon sinks had been switched off, so the CO2 being pumped out by the volcanoes had absolutely nowhere to go. For millions upon millions of years, every puff of volcanic gas from every eruption all over the world was added to the atmosphere, and none of it was ever removed. The process was agonizingly slow, but it was relentless. Molecule by molecule, ton by ton, the concentration of carbon dioxide in the Earth's thin, cold atmosphere began to rise. The planet had become a sealed pressure cooker. The ice was the lid, clamped down tight. And the volcanoes were the flame underneath, slowly, imperceptibly turning up the heat. For millions of years, the ice continued to win this war of attrition. The CO2 levels were climbing, but the planet's surface was so brilliantly white and reflective that it simply bounced the faint sun's energy back into space. The growing greenhouse blanket wasn't yet thick enough to overcome this massive albedo effect. But the volcanoes never stopped. Imagine the time scale. 10 million years, 20 million years, 30 million years. An amount of time so vast it is beyond human comprehension. All the while, the atmospheric CO2 was building. Scientists today who model this process estimate that the concentration of carbon dioxide may have reached levels hundreds or perhaps even thousands of times higher than they are today. The atmosphere would have become thick, heavy, and, for any animal that needed to breathe oxygen, utterly toxic. So what was the tipping point? How much CO2 does it take to melt a planet? After tens of millions of years, the atmospheric blanket of carbon dioxide finally became so thick, so dense, that it overpowered the ice's reflectivity. The super greenhouse was now trapping more heat than the planet's white surface could reflect. The global temperature, which had been locked at a stable minus 50 degrees for longer than the dinosaurs would one day reign, began to rise. At first, by just a fraction of a degree over 1,000 years. Then another. The great pressure cooker was beginning to hiss. The lid was about to blow. The first cracks in the prison would have appeared at the equator. Here, the sun's energy, now amplified by the colossal greenhouse effect, would have been at its most powerful. The surface of the ice began to soften, to turn from a hard, sterile desert into a vast, unstable slush field. And for the first time in 50 million years, a new sound would have returned to the Earth, the sound of running water. Rivers, born from the melting surface, would have begun to flow on top of the glaciers, carving deep blue channels into the ice. These rivers would have plunged into crevasses, carrying the warmth of the sun down into the heart of the ice sheets, weakening them from within. The great white mirror was beginning to shatter. The balance had finally tipped. After millions of years of accumulating in the sky, the volcanic heat had won. But this would be no gentle spring thaw. The Earth had just swung from the most extreme freezer in its history to the most extreme furnace. The apocalypse of ice was over. The apocalypse of fire and water was about to begin. The balance had finally tipped. After 50 million years of relentlessly accumulating in the sky, the volcanic heat trapped by a thick blanket of carbon dioxide had finally won. The ice was beginning to crack. The planetary prison was showing its first signs of failure. For the few hardy survivors huddled in the deep, this was the moment they had been waiting for an eternity. But this would be no gentle spring thaw. The Earth had just swung from the most extreme freezer in its history to the most extreme furnace. The apocalypse of ice was over. The apocalypse of fire and water was about to begin. The same physics that had doomed the planet to freeze were now about to doom it to boil. The ice albedo feedback loop, the runaway chain reaction of white reflects, was about to be thrown into a violent reverse. As the first patches of ice at the equator melted away under the super greenhouse effect, they exposed the dark ocean water or rock beneath. Where there was once a brilliant white mirror reflecting the sun's energy, there was now a dark black patch absorbing it. This small patch of dark water would heat up, which would help melt the ice around its edges, which would expose more dark water, which would absorb even more heat, which would melt even more ice. It was the exact same runaway feedback loop as before, but now working in the other direction. The fire of cold had been extinguished, and a new fire of heat had been lit, with the atmosphere choked with hundreds, possibly thousands, of times more CO2 than we have today. The greenhouse effect was almost unimaginably powerful. Once the melting began in earnest, the global temperatures would have skyrocketed. In the space of just a few thousand years, a geological instant, the planet's average temperature would have swung from a life-shattering minus 50 degrees Celsius to a blistering plus 50 degrees Celsius. That's an average of 122 degrees Fahrenheit. The planet had gone from Antarctica to Death Valley everywhere, all at once. The world had become a planetary-scale sauna, and the ice sheets didn't stand a chance. The thaw would have been the most violent and chaotic event in Earth's history. The sound would have been deafening. Imagine the roar of a billion Niagaras, a continuous, world-shaking thunder that did not stop for centuries. This was the sound of the great glaciers, miles thick, collapsing under their own weight in the new, suffocating heat. Colossal rivers, wider and more powerful than the Amazon, would have raged across the continents, carrying boulders the size of houses. Icebergs the size of small countries would have broken off the retreating ice fronts, crashing into a boiling, newly liberated ocean, triggering tsunamis that would have battered the emerging coastlines. The melting of an ice sheet that covered the entire globe would have unleashed the greatest flood in the history of our planet. As the water returned to the oceans, sea levels would have risen by hundreds of feet in a very short time, flash flooding the low-lying continental interiors that had been scraped bare by the glaciers. And then there was the rain. With the oceans now open and the air superheated, the planet's water cycle would have restarted with unimaginable violence. The immense amount of evaporation from the warm seas would have created a thick permanent cloud layer around the globe, triggering a hyper-hurricane that lasted for 2,000 years. The rainfall would have been torrential, a constant global deluge. But this was not life-giving rain. The atmosphere was still saturated with carbon dioxide, and that CO2 would have mixed with the water vapor to form a powerful carbonic acid. A global storm of acid rain was now falling on the continents. This acid rain fell upon a world that was uniquely vulnerable. For 50 million years, the glaciers had been at work, grinding entire mountain ranges into a fine, flour-like powder. The newly exposed continents were covered in a thick layer of this fresh, pulverized, chemically reactive rock. and the acid rain was now falling directly onto it. This triggered a second, even more intense wave of silicate weathering. The very process that had started the freeze was now working in overdrive to end the hothouse. This colossal chemical reaction between the acid rain and the rock dust began to pull the excess CO2 out of the atmosphere at an incredible rate, burying it as carbonate minerals in the ocean once more. The planet was now violently healing itself. But the healing process was just as brutal as the disease had been. So the world was saved, right? The ice was gone. The suffocating heat was slowly being drawn down. Was this a happy ending for the microscopic survivors who had waited for 50 million years in the dark? Not yet. They were emerging from their frozen prisons, not into a gentle new spring, but into another kind of hell. A boiling, storm-battered world with acidic oceans and a chaotic climate. The survivors had made it through the apocalypse of ice. Now they had to survive the apocalypse of water and fire. The war was over. The planet had survived a 50-million-year freeze and a multi-thousand-year fever. The world was now quiet again, warm and wet. But it was also empty. The old microbial world had been shattered. The survivors, emerging into the light for the first time in an eternity, found a planet full of death but also full of opportunity. The stage was set, the chemical soup was brewed, and the greatest explosion of creativity in the history of life was about to begin. The war was over. The planet had survived a 50-million-year freeze and a multi-thousand-year fever. The violent, chaotic rebirth of the great thaw was finally subsiding. The torrential, acidic mega-monsoons were softening into mere global rainstorms. The boiling oceans were beginning to cool. As the last of the excess carbon dioxide was scrubbed from the atmosphere by the pulverized continents, the planet's thermostat began to settle into a new, more temperate state. The world was now quiet, warm, and wet. But it was also fundamentally, irreversibly changed. It was an empty world, a blank slate, a new beginning. The survivors, emerging into the sunlight for the first time in an eternity, found themselves on a planet they would barely recognize. Picture the oceans in the aftermath. They were no longer frozen, but they were not the clear blue waters we know today. They were a murky, milky chemical soup. For 50 million years, the glaciers had acted as a colossal planetary-scale grinder. They had scraped and pulverized the continents, crushing mountain ranges into a fine, flour-like powder rich in minerals and nutrients. And the great thaw, with its acid rain and raging rivers, had just washed all of that material, trillions upon trillions of tons of it, directly into the sea. The oceans had been supercharged with a massive injection of phosphorus, iron, calcium, and silica. It was the single largest fertilization event in the history of life. The glaciers had spent 50 million years tilling the planet's continents, and the thaw was the moment all of that fertilizer was dumped into the water. The evidence for this chemical chaos is written in stone. All over the world, from Namibia to Australia to North America, the layers of rock left behind by the glaciers are covered by a strange, thick and globally consistent layer of limestone. Geologists call them cap carbonates. They are the chemical signature of the apocalypse. They formed as the superacidic, CO2-rich atmosphere reacted with the flood of calcium and other minerals into the warm, shallow seas, causing carbonate to rapidly precipitate out of the water like a chemical scum. These cap carbonates are the tombstone of the snowball Earth and the birth certificate of the new world that followed. They are definitive proof of a planet whose chemistry had been violently reset, and the atmosphere was changing too. The climate was beginning to stabilize, but more importantly, it was becoming breathable. The vast milky oceans, now a potent primordial soup of nutrients, were the perfect breeding ground for photosynthetic life. The cyanobacteria and algae that had survived in the slush and the dark now found themselves in a world of unlimited food and warm, open water. And they bloomed. They exploded in population on a scale that is almost unimaginable. A colossal planet-wide algal bloom, far larger than any in our modern world, would have turned the oceans a murky, vibrant green. And as these trillions of organisms photosynthesized, they began to do something that would change the future of the planet forever. They started pumping out a waste product, oxygen. The Great Thaw triggered one of the most significant oxygenation events in Earth's history. The atmosphere, which had been low in oxygen for billions of years, began to fill with the high-energy gas that all complex animals, including us, need to breathe. The long, slow work of the glaciers, followed by the violent chemical reaction of the thaw, had not only ended the Ice Age, it had primed the planetary engine for a new kind of life. A more active, more energetic, and more complex kind of life. So what did this new world look like to the survivors? To the simple sponges and the humble algae that had weathered the 50-million-year storm, it was paradise. It was a world of unlimited opportunity. All of their old competitors, the vast, dominant ecosystems of microbial mats that had ruled the planet for 3 billion years, had been shattered by the freeze and the thaw. All of their old predators, whatever simple organisms had existed to graze on them, were mostly gone, and the oceans were now an all-you-can-eat buffet of the exact nutrients they needed to grow and reproduce. It was a blank slate. It was like a forest fire that doesn't just burn the trees, but also vaporizes the old, tired soil and replaces it with a fresh, super-fertile new layer. When life returned, it wasn't just replanting an old forest. It was being given the chance to build a completely new kind of ecosystem from the ground up. But why now? Life had existed for nearly 3 billion years. Why did it take a planetary deep freeze to finally unlock the door to complexity? For the billion years before the snowball, evolution had been stuck in a rut. The boring billion. The world was stable, and the simple microbial ecosystems were so efficient and so dominant that there was no evolutionary pressure, no opportunity for a new, more complex form of life to get a foothold. The microbes had the planet on lockdown. The snowball event was the great disruptor. It was a mass extinction that targeted not species, but the entire ecosystem. It broke the microbial monopoly on the planet. The environmental chaos had shattered the old rules and created a window of opportunity for new, riskier, and more complex evolutionary strategies to finally have their chance. The stage was set. The chemical soup was brewed. The atmospheric engine was primed with oxygen. The old kings were dead and the throne of the world was empty. Life was about to get bigger, faster, and much, much weirder. The Cambrian explosion was about to begin. The planet was reborn. The survivors of the 50-million-year winter now found themselves in a planetary garden, bursting with energy and opportunity. The long, silent era of the microbes was over. The chemical foundations had been laid, the atmospheric engine had been primed with oxygen, and the evolutionary stage was set for the greatest and most dramatic act in the 4-billion-year story of life on Earth. The planet, having been pushed to the brink of death, was now about to truly begin living. Life was about to get bigger, faster, stranger, and much, much more complex. The Cambrian explosion was about to begin. Picture the oceans around 540 million years ago in the geological moments that followed the final recovery from the snowball Earth. The murky, chemical soup of the thaw has cleared, and the waters are now teeming with a riot of new life. But these are not the simple, slimy carpets of bacteria that had ruled the world for 3 billion years. These are animals, bizarre, alien creatures that swim, crawl, hunt, and hide. Creatures with hard shells, with jointed legs, with antennae, and, for the first time in the history of the planet, creatures with eyes. This wasn't a slow, gradual change. In the fossil record, it looks like a sudden, shocking revolution. For billions of years, the Book of Life had been writing a single repetitive sentence. Life is small. Then, in one explosive chapter, it wrote an entire library of new stories. This is the Cambrian explosion. It was the moment life went from being a two-dimensional, slow-moving carpet to a three-dimensional, high-stakes, interactive video game. And the rules of that game were simple: eat and avoid being eaten. So what happened? Why, after 3 billion years of simplicity, did evolution suddenly hit the accelerator? The answer is that the snowball Earth catastrophe had, by accident, provided the three things life needed to become complex: the fuel, the opportunity, and the motive. First, the fuel, oxygen. The massive algal blooms in the nutrient-rich oceans of the Great Thaw had pumped colossal amounts of oxygen into the atmosphere and the seas. Oxygen is a high-performance fuel for life. The simple microbial world ran on the metabolic equivalent of watch batteries, slow, low-energy processes. Oxygen allowed life to invent the jet engine. It's the chemical reaction that powers movement, growth, and, most importantly, predation. You simply cannot have large, active, hunting animals without high levels of oxygen. For the first time, the planet had an energy-rich environment that could support something more ambitious than a sponge. Second, the opportunity, a blank slate. The snowball Earth event was a mass extinction of a very particular kind. It didn't just kill off species, it destroyed the entire existing ecosystem. The old world, dominated by those hyper-efficient microbial mats, was gone. They had been scraped away by glaciers and poisoned by the chemical swings. This created a vast amount of empty ecological space. It was like a giant city where all the old established businesses had suddenly gone bankrupt overnight. This created a once-in-a-billion-year opportunity for new entrepreneurs, new animal body plans, to move in and try out radical new business models. All the jobs were suddenly available: the burrower, the swimmer, the filter feeder, the grazer. The world was open for business, and evolution was ready to innovate. And third, the motive, the invention of the predator. With the new fuel of oxygen and the new opportunity of open ecological space, the first true hunter could evolve. And the moment that one creature evolved the ability to actively hunt and kill another, the entire game changed forever. Predation is the single most powerful engine of evolution. The appearance of the first predator triggered a runaway evolutionary arms race. If you are being hunted, you need to evolve a defense, and you need to do it fast. So prey animals evolved hard, protective shells. They learned to burrow into the seafloor to hide. They developed the first muscles for swimming to try and escape. In response, predators had to evolve better weapons to overcome these defenses. They evolved sharper teeth and stronger claws for crushing shells. They evolved faster bodies for chasing down their prey. And most importantly of all, they evolved eyes. The evolution of sight during the Cambrian was a complete game changer. The world went from being a blurry, chemical-scented landscape to a sharp, high-definition visual field. Predators could now see their prey from a distance. Prey could now see their attackers coming. This poured gasoline on the fire of the evolutionary arms race. It drove the development of camouflage, of warning colors, and of even more sophisticated bodies and behaviors. The need to see and to avoid being seen was a relentless driver of complexity. This creative frenzy gave rise to some of the most bizarre and wonderful creatures in our planet's history, creatures so strange they look like they were designed for a Hollywood movie. In the fossil beds of the Burgess Shale in Canada, we have a perfect snapshot of this alien world. There was the Anomalocaris, the first great apex predator. Imagine a creature up to 3 feet long, like a giant swimming shrimp, with 2 large, spiny, grasping claws in front of its face and a square-shaped circular mouth filled with razor-sharp teeth for crushing the shells of its victims. For a brief time, this was the T-Rex of its day. There was the famous Hallucigenia, a creature so weird that scientists initially reconstructed it upside down and backwards. It was a worm-like animal that walked on 7 pairs of stilt-like legs and had a row of sharp defensive spikes on its back. There was Wiwaxia, a slug-like creature covered in a coat of mail made of scales and long sword-like spines, a perfect example of early defensive armor. And of course there were the trilobites, the poster children of the Paleozoic era. They were arthropods, relatives of modern insects and crustaceans, and they came in thousands of shapes and sizes. They were some of the first creatures to be covered in a complex, jointed exoskeleton, and most importantly, they possessed the first truly complex, compound eyes in the animal kingdom. So did all of these monsters and marvels appear out of nowhere? Was it really a sudden explosion? The truth is a little more complex. The genetic recipes for building an animal, the genes that control body plans, cell types, and development, were likely evolving slowly in the simple multicellular creatures like sponges that had survived the snowball period. The 50 million years of ice was not a time of complete stagnation. It was a genetic laboratory where the basic toolkit for building an animal was being quietly assembled in the dark. The end of the freeze was simply the moment that the chef evolution was finally given a fully stocked kitchen, a blast furnace, and an invitation to invent a whole new menu. The potential was already there. The aftermath of the snowball provided the perfect conditions to unleash it. The greatest catastrophe in Earth's history had given life its greatest gift, complexity. The silent microbial world was gone forever, replaced by a world of hunters and hunted, of eyes and teeth and shells. The ancestors of everything from the dinosaurs to the insects to you and me were all born in this single creative frenzy. The planet had not just recovered from its near-death experience, it had used the trauma to completely reinvent itself, to upgrade from a simple single-celled operating system to a complex multicellular one. And the lesson of this violent rebirth, this echo from a world of ice, is a chilling and powerful warning for the world of today. Of course, here is the final part of our documentary. Part 10 of Tentan, expanded to approximately 2,000 words. Begin script, Part 10 of 10. The planet was reborn. The survivors of the 50 million year winter now found themselves in a planetary garden, bursting with energy and opportunity. The long, silent era of the microbes was over. The chemical foundations had been laid, the atmospheric engine had been primed with oxygen, and the evolutionary stage was set. The Cambrian explosion, a frenzy of creation, had populated the oceans with the ancestors of every animal that would ever live. The greatest catastrophe in Earth's history had given life its greatest gift, complexity. The planet had not just recovered from its near-death experience, it had used the trauma to reinvent itself. And the lesson of this violent rebirth, this echo from a world of ice, is a chilling and powerful warning for the world of today. The story of Snowball Earth is, at its heart, a story about tipping points. It is the ultimate proof that a planet's climate is not a gentle, linear system. It is a wild, complex beast full of hidden tripwires. For millions of years, the Earth's systems can absorb stress, bending but not breaking. But if you push it too far, if you cross an invisible threshold, it does not just bend a little more. It snaps, violently, catastrophically, and it finds a new stable state that may be utterly hostile to the life that existed before. We saw it happen twice. A slow, gradual removal of carbon dioxide pushed the planet over one edge, and the runaway ice albedo effect took over, locking the world in a freezer. Then, a slow, gradual addition of carbon dioxide pushed the planet over another edge, and a runaway greenhouse effect took over, plunging the world into a furnace. It's like a ruler that you can bend and bend and bend until, with just one tiny bit of extra pressure, it shatters. Snowball Earth is the story of our planet shattering twice. For the last 10,000 years, humanity has been living in a period of almost unbelievable climate stability, an interglacial warm period called the Holocene. This gentle, predictable climate is what allowed us to invent agriculture, build cities, and create a global civilization. We are a species that was born and raised in a calm, peaceful spring. We are so used to this stability that we have come to think of it as normal, as the default state of the planet. The story of Snowball Earth is a terrifying reminder that it is not. The Holocene is the exception, not the rule. The Earth's natural state is one of violent, chaotic swings between extremes. And the story of the snowball teaches us that the switches for those swings can be flipped with surprising ease. And that brings us to the present day, because right now humanity is conducting its own uncontrolled planetary scale experiment on the Earth's climate. We are pushing the system. We are pumping carbon dioxide into the atmosphere from the burning of fossil fuels at a rate hundreds of times faster than the volcanoes that triggered the Great Thaw. We are, in effect, recreating the conditions of the Cryogenian, but in reverse and on fast forward. We are pushing the climate boulder that has been sitting peacefully at the top of the hill for 10,000 years, closer and closer to the edge. And the ghost of Snowball Earth is screaming at us to pay attention to the warning signs. The most direct echo is happening right now in the Arctic. The melting of the polar sea ice is a perfect modern-day demonstration of the ice albedo feedback loop. As the bright white ice melts, it exposes the dark, heat-absorbing ocean beneath. That dark ocean absorbs more energy from the sun, which warms the water, which melts even more ice. It is the exact same chain reaction that took control of the planet 700 million years ago, a fire that feeds on cold, now playing out in miniature at the top of our world. Then there is the threat of the permafrost. In the vast frozen soils of Siberia and northern Canada, there are hundreds of billions of tons of carbon stored in the form of frozen organic matter. Trapped with it is a vast amount of methane, a greenhouse gas far more potent than CO2. As our planet warms, this permafrost is beginning to thaw. If it crosses a tipping point and begins to release its ancient carbon and methane into the atmosphere, it could trigger a massive, unstoppable spike in global temperatures, a geological burp of greenhouse gases that would be completely outside of our control. This is a chilling parallel to the slow, relentless buildup of CO2 from the subglacial volcanoes, a process that once started could not be stopped. The story of Snowball Earth is not a prophecy. It is a blueprint. It is a user manual for a planetary system, revealing the hidden tripwires and the terrifying consequences of crossing them. But there are two profound differences between then and now. The first is us. The survivors of the snowball were microscopic organisms and simple sponges. They could endure for 50 million years in the dark, waiting for the planet's geology to save them. Our global civilization cannot. Our agriculture, our cities, our entire way of life are fundamentally dependent on the fragile, stable climate of the Holocene. We do not have the luxury of waiting out a million-year climate shift. The second and most important difference is consciousness. The cooling and heating of the Cryogenian were driven by blind geological forces. The creatures of that time were innocent, helpless passengers on a planet that was driving itself off a cliff. We are not. We are the first species in the 4 billion year history of life on Earth to understand the mechanics of its own climate system. We are the first to be able to read the warnings written in the ancient rocks. We are the first to understand what a tipping point is, and to see one approaching. The story of Snowball Earth is a gift of foresight, a message sent to us from the ghosts of a long-dead world. And what a story it is. The oxygen we breathe is here in abundance because the Great Thaw supercharged the biosphere. The very bodies we inhabit, with their complex organs and specialized cells, are a direct inheritance from the evolutionary arms race that was triggered in the aftermath. We are, in the most literal sense, the children of the snowball. The unbelievable resilience that allowed a few microbes and sponges to endure 50 million years of hell is the same resilience that is written into our own DNA. That ancient catastrophe is the reason our world is not still a simple, slimy, microbial mat. It was the violent, necessary crucible that forged the blueprint for all complex life. In the end, this ancient apocalypse is not a story of despair. It is a story of the unbelievable power of life and the equally unbelievable power of the planet itself. It proves that the Earth is more resilient than we can imagine, but also more violent than we can afford. The ancient ice has left us with a choice. We can ignore the warning and continue to push our world systems towards the same kind of tipping points that were crossed 700 million years ago. Or we can be the first species to take the blueprint of our planet seriously. We can be the first to understand the rules and to choose to act not just as passengers, but as guardians. The next chapter is not written in stone. It is being written right now by us.